Hey everybody, this is Mr. P, and I'm coming with you today with your e-learning lesson for Thursday, May 14th. So we're continuing in our electricity unit. So delving more into the specifics of electrical circuits and looking at different types of electrical circuits and how current flows through those circuits. Okay, so we talked a little bit about circuits when we talked about current, right, which is the flow of charge through an electrical circuit. And basically, okay, if we define an electric circuit is just a complete path through which charge can flow. Okay, we have to have a complete closed path for charge to flow in order for it to be a circuit where current can flow. So remember, the current is the flow of charge. A circuit is the pathway through which that charge flows. And we'll be looking at diagrams of circuits which show one or more complete paths in which charge can flow. Okay? Arrows are going to show the direction of current. Remember, we talked a little before of how current flows from positive to negative within a circuit. Switches show places where the circuit can be open. Okay? So if a switch is open, the circuit is not a complete loop, and the current stops flowing. Okay. This is called an open circuit. If the switch is closed, the circuit is complete and charge can flow. This is called a closed circuit. So if we think about the lights and the light switch right now, the circuit for the lights is closed. When the switch is up, circuit's closed, current's flowing, we have light. I flip the switch, I open up the circuit, charge is no longer flowing, current's no longer flowing, we don't have light. Flip the switch back up, I've just closed the switch, closed the circuit, now current flows again, now we have light again. Okay, and just think of a little animation here real quick. So notice in the circuit here, we got a couple light bulbs here. They're not lit up. Why are they not lit up? Circuit is open. There's not a complete path for the charge to flow. But if I close the circuit, now we can see there is current flowing through the circuit from positive to negative, like we talked about. We'll come back to this in a little bit when we talk about the specific types of circuits. But again, we can see a closed path, right? We've got a source of voltage, and we got current flowing through the circuit. And if I open it back up, right, now I've opened the circuit, I've broken the circuit, there's not a closed path for the charge to flow. Alright, so in just a moment we're going to look at two different types of circuits. So one is going to be what we call a series circuit, the other one is going to be what we call a parallel circuit. So there's some key differences between those two circuits. So, in a series circuit, which is actually what we just looked at when we talked about the switch just up above there and the closed path. So in a series circuit, charge has only one path to flow. Like there's only one path through which the current can flow. If we put bulbs, if we have bulbs in a series circuit, if one bulb burns out in a series circuit, it breaks the circuit, it opens the circuit, and guess what happens to all the other bulbs? They burn out too, okay? Because there's no longer a closed path. It breaks the circuit. There's no longer a closed path for which the current to flow through. The bulbs themselves are actually a source of resistance. And if you recall resistance, what does that do? That restricts the flow of current. So guess what? If we have more bulbs, adding more bulbs to a series circuit is going to increase that resistance. Okay, what happens when we have more resistance? What happens to the current? Current decreases, right? As there's more resistance, that means more restriction on the current. So the current decreases, and each bulb shines less brightly. So as we add more bulbs, they shine less brightly. They get dimmer and dimmer as we add more bulbs. All right? So let me show you an animation of what happens here with the series circuit. So in the top circuit, notice we have a circuit with two bulbs. We have a battery as our voltage source. In the bottom circuit, we have a voltage source as the battery, same as the top, but we have three bulbs. So in the bottom circuit, we have more resistance. Remember, the bulbs act as resistors. So adding more bulbs adds more resistance, which means what? Less current. So let's go ahead and close both switches and take a look at what we got. So as we can see, the bulbs on top here in the top circuit appear to be shining more brightly than the bulbs in the bottom. Why? Because the bottom circuit has more resistance. More bulbs, more resistance, which means less current. And actually, remember, less current means there's less voltage across each of the bulbs. So if this is a 9-volt battery, let's go ahead and see what the voltage is across each light bulb. So 4.5, there's 4.5 volts on each light bulb, right? So it makes sense, 4.5 and 4.5, that's 9, right? And if we look at the light bulbs down here, same 9-volt battery, but each of these light bulbs is going to have a voltage of 3 volts. So that would explain why they're shining less brightly, okay? Because there's less voltage. And obviously we know there's less current because there's more resistance. Okay, so again, that explains the less brightness of the bulbs in the bottom circuit. And we talked about what happens if we, take out a bulb or a bulb burns out. So let's say, bulb burns out, guess what? The other bulb burns out too. Okay, because there's nowhere for the current to flow, the circuit is broken. So that's what happens in a series circuit. Now, let's go ahead and transition to the next type of circuit. Okay, so a parallel circuit. A parallel circuit is a circuit where charge or current has more than one path to flow. Remember, series circuit, there's only one path for the charge to flow. So a parallel circuit, so two or more paths through which charge can flow. So if one bulb in a parallel circuit burns out, charge can still flow along the other path, okay, and the other bulbs won't go out. All right. In your home, okay, electrical circuits are wired in parallel so that they can operate independently of each other. Okay, so let's say your circuit for your air conditioner is tripped. It is opened up. It's broken. Then that's not going to affect the rest of your house. So your lights will still stay on, your TV will still stay on, so it doesn't affect the rest of the electrical circuits in your house if one circuit is broken. Okay, that's an advantage of parallel circuits. All right, so we can see by the diagram here, right, there's two different paths through which a charge can flow. So we got our voltage source, that's what this represents here. And again, going from positive to negative, the current can either take this path through the first bulb, go back like this, or can take the path through the second bulb. So there's two different paths, and parallel circuits can have more than two paths, right? We're just showing one where there's two different paths. So obviously if we take out one path, it still has that other path, which would explain why one bulb burning out wouldn't cause the rest of them to burn out. Let's go to an animation of a parallel circuit. Okay, so let's go ahead and close the circuit. Notice here's our voltage source, the battery, and we have two bulbs. Again, this is in parallel. Okay, so there's going to be two different paths through which the current is flowing. Right, so current can either flow through the path through the first bulb, or the current can flow through the path that goes through the second bulb. And we just go from positive to negative, right? That's the direction of the flow of current. Now, notice that both of these bulbs appear to be equally as bright, So, same 9-volt battery as our series circuits. Let's check the voltage across each of these light bulbs. Okay, so there's 9 volts going to that light bulb. And there's also 9 volts going to this light bulb. So they're going to be equally, when they're in parallel like this, they're equally as bright because there's the same amount of current flowing through this light bulb as there is through that one. Okay, basically it's the currents equal through both of the paths. Remember, in a series circuit, we added more light bulbs, they got dimmer. Okay, right, because they added more resistance, and there was only one path through which the charge could flow. So adding more resistance to that path, okay, decreased the current, and then there was less voltage and less brightness. Okay, they got dimmer. But if we have multiple paths, okay, they're each going to have the same current flowing through them, which means the same voltage across each light bulb, which means each light bulb is going to be the same brightness. Okay? All right. So, again, that is a parallel circuit. Okay, so 2 or more paths for the charge to flow. Okay, and one bulb goes out, the others can stay lit. Okay, remember, that's different from a series circuit because a series circuit only has one path for the charge to flow. One bulb goes out, they all go out. All right? So that's the key difference between a series circuit and parallel circuit. And you will have a short assignment. Again, it's just ask a few general questions about your understanding of circuits, parallel, series circuits, some specific detailed questions about those. And that will be on Schoology in the folder for May 14th. So until next time, we'll see you guys later.